Anyways, so hi, I'm Darragh Grealish. I think I've presented a few years ago once on the CNCF Meetup stuff. So what I'm going to show today is a bit different than public cloud or anything, but maybe it will help you guys like get an idea of what it looks like when you go, below the operating system, below virtualization, and what happens there. So so I wrote a blog post maybe like 2 to 3 years ago on bare metal cloud and VMware on bare metal cloud, and it was about how you could basically stand up a whole VMware ESX instance and vSphere in about like 20-25 minutes. And it was finally infrastructure as code. This concept of defining your architecture actually could come. You could bring this forward and bring it down to hardware, network switches, everything like this. What would you kind of do in public cloud with AWS and VPCs and stuff? The relationship with ARM, and I'll explain that later, is right now, if you look at your laptops, they all have this Intel Inside logo. So like, who has a Mac M1 or M2? Okay, cool. See, that's like half the room, almost half the room. This laptop I have here is just to prove it to you, is a Qualcomm. It's also ARM. It's actually based on the similar cores that are in AWS and the Graviton, Neoverse, or the Ampere Ultra, which I'll show you later, that Oracle and Azure are doing. And if you look at that, Snapdragon is usually what you see on phones, and now you see that entering this world, it's entering this world. So anyways, let me just give you a few words about me. So who the hell is Darragh? So this is me. I don't know why I have this here. So I carry much of these labels. So one thing I'm going to talk about today is ARM, and there's this called ARM Ambassador Program. You guys are welcome to sign up. It's like the Docker Captain Program or AWS Community Builders Program that you might know. And I like to sit between the cloud and the hardware, because I studied embedded systems, and I like that stuff still, but that doesn't pay the bills. Doing stuff in the cloud does. So this is where I come from. And this is a piece of hardware we got about 1.5 years ago when it was in development from a company called Adlink. So like HP or the beamer up there, it might be Panasonic or whatever it is. I mean, when a vendor comes and wants to build something, and they want to build on certain technology, like a processor or whatever, they have to build, a platform inside it. And so, and then they have to get the CPU. So someone has to license you the silicon, like Apple with M1, which they call it Apple Silicon, but it's really a licensed implementation from ARM. So it's like Intel Inside. And then Packet is the hosting provider, which then hosts a server that's manufactured with a CPU from Ampere, and the person putting all the boxes and chips together is then Adlink. And then who's licensing then that kind of intellectual property of the CPU is Adlink. So anyways, what has happened till then is that when you start to introduce different CPU architectures, you need some sort of standardization, because if we're software developers or we're building software and compiling it towards a target architecture, we need to compile that towards some sort of standardization. And this is where a huge adoption with mobiles, I left my mobile over there, but the mobile I have is like also Qualcomm mobile. It's a OnePlus. It has a Qualcomm chip. So there's a huge adoption of ARM architecture in the mobile world, in the low power devices world, in tablets and all this. And what that happened the last few years is it actually motivated a lot of early adopters into, well, hold on a sec, I have 4 cores or I have 8 cores on my mobile device. I can sleep 2 or I can have 2 high performance cores, and I can develop software that is working within the physical constraints of my device. I don't want the phone to get hot in my pocket. So that's why phones become so powerful, because developers could develop and optimize towards the hardware, not have this unlimited resource behind an API. So what if you take that to the data center? What if you take that to the edge? And that's what this Fling project at ARM was about, So ARM have what's called, So in the CTO office of VMware, there's a kind of a cloud native group. I don't know if it's reorganized a little bit, but the guy who showed you all the logos there, like OpenFast and everything, who were a part of it. That's like a project. Like Fling was a project on the side, and to see would there be a motivation. And I still think there is. So the hardware I'm going to show you today, unfortunately I didn't bring it, but we will log into it, is this. This is the Adlink development workstation. So normally if you're a hardware vendor and you want to develop out a platform that you're going to offer to run workloads on, you usually start with, looks like a gamer's PC, you know. And what you have here is, maybe I'll use the pen. You have here like a HPC, it's a big package that you can change, and there's like 2 motherboards in there. And this particular device is, it's for the size of it, it's a rocket. It doesn't even need 750 watt power supply. This thing runs around, just that green part there with the CPU and RAM runs about 25 to 35 watts. So it's ridiculously low. And it's a water cooled just so that there's physically room to work around the device, but this thing is really efficient. This one specifically was, you can buy it, it's about 3,500, but you can also test it online. So this is this blue button there, you can go to a form and they give you remote access to one. One thing it has, which is really cool, is the firmware is open source, the whole thing. So the what we call a board support package, the BIOS, this EDK2, this is UEFI extended development kit. So this is, I can program my own BIOS. This particular device has 2 BIOS chips. So I have a fallback. Like if you rip open your MacBook, some of the older versions, they actually have a little a connector on the board where you can bring up a second bootloader or a BIOS on an Apple. So you can physically rescue an Apple device if you Google hard enough. Anyways, why is that important? And what I'm going to do is talk a little bit about ARM and their program, and how that led me into this whole, you know, VMware or VMware on ARM, VMware on ARM, and then Fling project. So, like I mentioned about this Intel Inside logo, so you might see vPro or something written beside it. From an Intel perspective, that's verifying or standardizing the platform. That means HP or Lenovo, whoever built the device, actually work towards some sort of hardware specification that matches this software specification on top. Otherwise, their stuff wouldn't run. Linux wouldn't boot or Windows wouldn't boot automatically. That's what happens over here on the right side, the system ready program. Then you've got security, which is really, really important. So when you dive into security on the hardware and all the way up, it's actually terrible. It's really, really bad. I would say Apple is one of the best. Even though it looks like a closed ecosystem, they're using UEFI, which is part of the EDK, which is EFI development kit. So that's coming from Intel. ARM is also part of that, which is good. Then there's TPMs. You guys have heard TPMs? TPM is, even though it looks like it's an open source or it's kind of an open protocol, it's not really. It's really ugly. That's partly because a TPM is a physical little microcontroller chip on your computer, and it's only as fast as that physical chip. It doesn't benefit from any of the cryptography acceleration on your CPU. So that's why the security part is important. How do we define accelerated security? And then ecosystem. This is what we're talking today. You know, if we build a piece of hardware, and if you're a small startup building hardware like Adlink would have been years ago, or Solid Run, or the other guys, which probably you've never heard of, you know, how did they match the same level of support as HP or Dell? And that's why it's really important to extend this cloud native ecosystem down to the hardware, down to standardization specifications, but not force it, you know. So this is another project we work on is Parsec, which is a libraries to abstract the security providers below, so that the developer doesn't have to divide specific security functions towards things. So anyways, this is where I got into it. Initially, we worked on this is a CNCF project, Parsec. Anyways, let's get to it. I'll come back to that later. But that's the device. We have 2 of them. They're not very noisy at all. It looks like a gamer PC, but that's just because it's easy to prototype physically. It's what's called Ubuntu certified, so it also runs Ubuntu out of the box. So what I mean by that is I can take a USB key, and even though this is a Qualcomm processor in this laptop, that's an Ampere Ultra processor, which is the same as same CPU core as an AWS Graviton. So I can literally take the same build of Ubuntu with the bootloader, and it'll boot in Amazon, it'll boot in Azure because they also have Ultra, it'll boot this, and it'll boot on that laptop. And the reason why that works is because that hardware vendor followed this process. And that meant that this means maybe all gibberish. But what it basically means is that they made sure that they followed some sort of compliance. And that compliance, the Linux kernel matches. And then it gets tested. And then what they do is they get that system ready label, like that Intel Inside logo. And that means then, okay, Ubuntu can verify it. So the reason why this is really important for VMware and ESX is that if you write software that's virtualized and the hardware is exposing the capabilities of the virtualization is exposing the capabilities of the hardware, then this stuff is going to run. So this is where I get to the point. So anyways, these are an example of 3 systems I showed you. This is actually, if you ever want to build a cool, like a kind of hacker kind of space hardware for your own desktop and run something around 15 or 20 watts, this is cool. This is the Honeycomb. It's really well developed. ClearFog is the one with the 100 gig interface, and it's Init 7 or Fiber 7. Who knows? Anyone have that super fast internet? The 25 gigabit internet they offer. This is the smallest and cheapest device you can buy where you can actually get line rate speed. The one of the ClearFog. The Honeycomb one, you drop a graphics card in there and you have a super, under $1,000 you have a super cheap, really fast 16 core ARM PC. And this is more expensive, this is more a hard one. This is basically what Azure is using. I think they're using Dell implementations of it. So again, if you watch the wattage, it's very low. It's 650 for such a device. And if you go maybe the same 1U size, it'll probably be 2 watts, 2000. And there's a comparison of some of them. Now, why the effort for Fling, VMware Fling on ARM has been, the project has been going on for so long is that if you look at all of the stuff in here, like if I have LAN cards, if I have the WAN card, I might have iSCSI and all this, all of those vendors have to build up support towards the ARM architecture. It's the same thing with Apple. Apple spent like 2.5, I think 3 years really investing in the software stack to make M1 work. And then there was M2. Maybe even longer, we don't know, because they keep everything closed door. I know this Lenovo laptop, this Qualcomm laptop, was maybe, I think, 3 years into it. And then they could build a laptop. So there's a huge amount of effort in making platforms, software compatible. Anyways, so let me go to show you a bit of a demo. So how do I get rid of this? Keep whatever. So what I'll do is, so what I have done is I've set up ESX instance. So I just have one instance, and what I've set up is I have remote access to it. So let me the login again. So I have 2 things here. Let me just, when I changed the beamer, I had a different. Where is my other window gone? No, that's not it. I'll just open it again. Localhost. So it was so warm this week that I basically set up remote access to this box because I couldn't work on it otherwise in the office. So this is the lights out. So in a server you have a background connection. You can attach to the server, you can attach a virtual floppy disk and see. So this is what we call the HP ILO or iDRAC and Dell. This is a reference architecture of one. So here you can see the sensors and everything. You can see some of it doesn't report properly, but the voltage does. And that's part of it's a hardware development platform. They haven't finished that system ready specification. But I have remote access here, and I can log in. And here you see the VMware the Fling on ARM. So this is kind of a special build. So here you see the ARM limited NeoVerse N1. If you do CPU info out on a Graviton instance, you'll get the same response. So it's also a NeoVerse N1. This specific model is 80 core, and it's pretty fast. It doesn't take long to set it up. Some notes on setting it up. So this one, you go in, you sign up to the VMware technical preview, and in the technical preview, there's just some disclosures that says, okay, I'm willing to use this, it's experimental and everything, and then it takes about 10-20 minutes. Some notes on setting it up and everything is you should manage the storage thing. So VMware has this thing where when you set up ESX, it'll always automatically go for 115 or 116 gigs on the VMware FSL partition, and then you'll have nothing left. So you have to actually kind of force that. So some notes on this is that, where is it? I wrote the note here. Yeah, here we go. So notes on this, yeah, auto partition set that. So the steps are quite simple. If you pick like a Raspberry Pi, if you pick anything that carries this ARM system ready label device, which is about like 20 or 30 of them, like some of the example devices I showed you, it's essentially just runs out of the box almost. Not on the same ISO file, but you have to download a separate one. Some stuff is broken, like TPM, like I mentioned later. A lot of that is not part of the entire system ready specification because they need to reach what's called a PSA level, so they have a generic interface for things. So things like doing TPM and things like this is a bit broken, but you know, security is difficult, and it's a very fragmented industry, and it's very vertical focused because with security. But anyway, let's log into it and show you. Here we go. So here we go, cloud. So this point is a bit slow. I think it's something to do with the browser. So how many of you guys work on VMware stuff? Like on this low level? 1 or 2? Yeah, okay. So this was my life like 7 or 8 years ago, you know, and it was very much click ops, you know. So the second part of the day was I was going to show you why I could submit the talk quite easily. It was that you had to live within this, and you know, it took them years to bring a web interface. You usually had a VMware vCenter on the computer. What's wrong with this? And if you're a developer and you come from like working with things like Ansible and stuff, then maybe before that Puppet, I mean, there was a lot of things blocking, you know. So here's the instance. I had it up since last night, sometime around 9. I redeployed it, and it's quite simple. Not many of you are familiar with this, with such an interface. Okay, so this is a typical like console interface on a virtualization host. This is the VMware ESX specific. Then there's vCenter, which ESX speaks to. And what you do is you set up your different ESX nodes and you join them. And the 3 important things you really have is like, okay, storage. Do I have local storage? Do I have storage on my device? And so in this case, I have a piece of local storage. I would have storage adapters. That's another difficult thing for that usually has challenges, because sometimes you have storage over let's say fiber channel or a different hardware interface, like software iSCSI, for example, which goes over the network interface. And usually you're doing that more so than local storage, because it's storage over the line is faster. Then you would have maybe hardware-based adapters that would then expose that storage, and you have to have a data store. So in this case, I just have a simple local data store. I have just one network. So usually you might have multiple if you're doing segmentation and everything. And in this case, I have an Ubuntu box. So this is an Ubuntu-based ARM. And so what I did is I just prepared it to show you guys. And hopefully the demo gods are with me, because I think it does work. It just doesn't like my SSH tunnel. Perfect. Okay. Cool. So you see there it says Ubuntu 2022. It's discovered it's the ARM daily build, and now it's doing some signing. So some of the recent implementations of Ubuntu have a lot of this signature and signing stuff. So once it gets through that, then you get the interface up. Here we go. So I wanted to show you that it's working. What else? before I move on to the other topic, any questions on VMware and ARM, or no? Anyone like hacking on Raspberry Pis and stuff like this? Yeah. So if you so Raspberry Pi has support for this as well. So Raspberry Pi is a bit of a, I mean, it looks like it's an open platform, but it's actually a little bit proprietary because, of course, they had to get into the space. They built it vertically, and now you can actually flash the BIOS on your Raspberry Pi. So if you put UEFI, like UEFI or PI3 and VMware Fling, you'll see that it's totally possible. You can download the ARM edition of VMware Fling. So if this is their main website, I'll share the links in the picture. So here you see you can download the various different options. There's like all the different platforms. So these are the platforms that have been doing some tests with VMware on ARM. And they've been doing that project since about, I think, 4 or 5 years. So if you look at the Raspberry Pi, it basically just gives you a PDF, and inside that there's some instructions. Oh, sorry, it didn't like that so like this. It's a bit funny that it's all buried in PDFs, but you will find stuff out there on that. But the interesting thing is, what you can do is, you can actually virtualize the Raspberry Pi on this, on VMware. So you can actually download the Raspberry Pi, Raspbian OS, and then run it inside this hardware. And that's because the Raspberry Pi have made an effort that their software implementation is this system ready, that they upstream all the board support packages, all the kind of hardware-based support up into the Linux kernel, and then they do the same on the other end. This is why, for example, if you do Linux kernel, it's a Apple Silicon M1 or M2, you'll find, finally there's mainstream support for M1. And the reason why that's important is that if you want to even virtualize Linux on an Apple platform, or even virtualize it inside, a VMware on ARM, you need to upstream the support packages, because if I go back to that mention, just to kind of close off the ARM discussion, if I go, so I wanted to show you, so like if I go, because I know there's some technical people here, BSP, DRT, I think it is. I think DRT. There's an acronym. That industry is full of acronyms. Yeah. Board support package. So behind the board support package, what you generate is your various device blobs, binary device blobs, and that has to be uploaded on. That has to be upstreamed into the kernel. So what I wanted to show you is there, exactly. It's really deep in the Linux kernel package somewhere, anyways. But when you get into it, you'll find a huge list of a device tree. That's what it's called. It's called that, BSP device tree. Yeah, here we are. Here, exactly, a patch. So this is the whole reason why Linux runs on ARM. And what I wanted to get across today, and what I read recently is like I mentioned about this process, where someone goes and develops hardware, they have to define it, they look at the architecture they're going to define it. The IP selection means that they decide, what kind of intellectual property we want to buy from the Qualcomm or augment on top of ARM, for example. So Apple, what they did is they said, okay, well I'm going to write my own IP, but I'm going to write it towards running the ARM architecture, so AARch64. So that's called ARM v8.2 or ARM v9. These are versions of that instruction set implementation. Okay, a lot of gibberish there. And then they have to then design it and do it. And you remember there's a hardware process going on. So you can only do this in a waterfall process. It's hard to iterate through it. And by the time to get to this point, they need to then start writing the device tree, we call it, software files, and upstreaming it into the kernel. Otherwise, that when you download CentOS or real Red Hat stuff or Ubuntu, this stuff won't run on your platform unless you give the customer a specific software build. So this is why it's really important. And like I asked there earlier, how many of you guys have Apple devices with M1 and M2. I mean, so far it was like kind of almost half the group, and it'll just grow. So if people are developing natively on ARM architecture in a hardware platform that has a critical mass, I mean, you're not going to go cross-compiling back to Intel just to run it in the cloud. You're going to, natively go directly to ARM architecture. So this looks funny because here, and nothing against VMware, they say there's no need for multi-cloud. But then you look here, and you look virtualization of AI. AI requires specific extensions in the CPU to accelerate that. And if you run on an open architecture that you can bring your own intellectual property to accelerate the chip, then it makes more sense this is developed in ARM and not just Intel, or in both ecosystems. So this was 2 days ago. That was 1 day ago. So I came back from the, ARM has this big partner meeting every year. They do it since 1992. It's like a NDA kind of a thing. But one thing that was clear there, and you'll see it on their website, is what we need to accelerate virtualization is what's called DPUs. So not just like deep processing units, it's called data processing units. This whole thing of large language models and AI and everything, and ML, I mean, a lot of that is blah, blah, blah terms, but all in the background, it's basically ML ops with large language models with foundational images, which means data. So if I can't annotate data, if I can't, classify it and everything, then, and if I don't have power to do that, then I can't reach virtualizing AI. So that was just my feedback on that. And to finish on this thing, here's an example of like a typical use case. So we all heard about this promise of 5G and blah, blah, blah. And so how we came about this hardware and started testing on it is that we were asked to look at, okay, how could we build a developer experience for 5G? And not just 5G as a communication or connectivity, but also it allows fast connectivity with the promise that you can have edge compute. So if you think about someone who's developing across a device on the edge, your phone or mobile app, someone who's developing across edge location, it could be, some computers in a factory, could be a PLC that then pushes data to an ERP system, an SAP or whatever. But that's taking an application that was fundamentally on a big device, running it on the edge, and then you want to augment it in the cloud. You're not going to have a special, pipeline to, let's say, deploy an ARM or Android NDK kit for this, which is probably on an ARM architecture. Then you're going to do Intel here, and then you're going to do ARM there again. And then your laptop is maybe a MacBook. That's just, no one's going to do that. You'd rather make it all run on my laptop. It runs my laptop, and then you want to, target the deployment to the target architecture you can. So that's where it's really these devices will dictate what the whole edge cloud landscape will look like, and that's why, one thing that came out of this was we're not going to be building more data centers. It's too expensive and use too much power. So if you're able to develop on hardware platforms that use as much energy as your kind of really fast phone, you'll be able to know that, okay, I'm saving the planet somehow by deploying this on more energy efficient CPU architecture. But anyways, then at least, I think something you should definitely check out is here's some links on some of the work I did. If you're going to try this yourself and virtualize VMware stuff to test it out, realize one thing that's quite difficult with virtualizing virtualization, nested virtualization, is this EL1, EL2, which means exception level. So when you log into your computer, you're usually on exception level 0. It's safe. If you need to go and have, let's say, deeper access to the CPU, you need to go up on exception level 2 and 3, for example. So that's hard to virtualize. And this is an example where I hit a roadblock with QEMU to run the ESX Fling in QEMU. So in the end, I had to do it on the hardware. And if you want to play with the hardware and have some good fun, I recommend you to check out Equinix. This is called, have you heard of a bare metal cloud? And you guys? No. So you know how, and who does Terraform stuff here? Okay, you do so there. So you know how we describe our software, let's say EC2 instances and all the stuff we need for Kubernetes and things like this, with Terraform, you could do the same for hardware. And so have a look at what's called Equinix Metal. They bought a company called Packet.net. They were really, you know, they loved cloud native and how cloud native was being adopted and all these developer tools. And what they did is they brought that back down to infrastructure, really down to like bare metal, like configuring switches, routers, you know, doing all that kind of infrastructure. And they started from that point on. And so if you're, this is where you can actually play a lot with ARM architecture and have access. So here I did a deployment of the ESX, and I wanted to show it earlier, but I think it's broken. But yeah, I managed to break it somewhere there. But anyways, I think that's for another day. Let me go back to the slides. So just before I finish, so who's 56K Cloud? We're a company. I used to work for Vision, by the way. It's a really cool company too. We're based in Winterthur and Sion, and we do a lot of this work between, how do you say, like the developer tooling, infrastructure automation. We have some work on IoT because we're working from, they say, the ARM world, and we have 16 people in Switzerland, but about 70% of our work is outside Switzerland. Interesting enough, it's just a lot of the companies we work for have headquarters in Switzerland. So yeah, check us out. Here's some links to catch up, to look at what I was doing. So I recommend you try out the Fling project before it closes or finishes. If you're interested in this Ampere box or that hardware I used, I forgot that link. If you go to IPI.wiki, here you can buy really expensive Raspberry Pis. Yes. And if you're curious about the hardware I was using, that's, if you want to make it yourself, that's the board. And just don't fall off your seat. But if I go here, where is it? I can go buy now, and you can see 128 cores will cost you 5,000. And you can even get more gigabytes, more space. Yeah, you can break the 5,000 thing. But you can try it for free. There's this button called Test and Run. Click that. Oh no, where did it go? Oh, here, apply now. Fill that out, tell them you know Darragh, say system ready, blah, 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 and you'll get access for, usually, it's like 2 weeks, actually. It takes them so long to set it up, they let you play with it for 2 weeks. So there you go, you can have access to a virtual one, it's in Taipei. But I think that's it. I'll bid you farewell. I think 2 things to check out is, that's the Cloud Native Meetup, Cloud Native Day Burn, 20th, 21st of September. Who's going? A few guys? Okay. The other one is Swiss Cloud Day. Did anyone register? Okay. If you really want to go, because it's actually a bit close, just say CNCF group, something like this. And we're happy, we're sponsors there, so you can check out more of these demos, not the hardware, but other demos with us. So that's us. And the agenda is already up, so I recommend you can go have a look at it. And if you go level 400, I don't know for level 400, level 300, there's the interesting talks. Okay, thanks.